Assalamualaikum. Hi everyone. Today we will learn about stoichiometry, especially in solution. Objective of our lesson today is to calculate the product based on the stoichiometry in solution and to calculate limiting reactant in solution. There are three components in preparing solution. The first one is solute. Solute is the substance that dissolves to form a solution. The second one is solvent, the substance in which a solid dissolves. And the last, we have a solution, a mixture of one or more solids dissolved in a solvent. Now, we learn how to calculate molarity. Based on this picture, what is the molarity of an aqueous solution that contains 0.715 mole of glycine in 495 milliliter? Okay, as we know, 1 liter equal to 1000 milliliter. So we have a two-way to write it in conversion factor. The one is 1 liter over 1000 milliliter or 1000 milliliter over 1 liter. It will depend on what we want to cancel out the unit. Okay, in this calculation, 0.715 mole of glycine should divide by 495 milliliter of solution and times to 1000 milliliter over 1 liter because we want to cancel out the unit milliliter. At the end, we left the unit mole over liter represented by molarity. So we have 1.44 molar of glycine. Now, we're looking forward the method how to calculate mass of solute. Based on this figure, we have 1.75 liter of phosphate buffer solution with the molarity 0.460 molar. However, we want to know how much the solute needed to prepare this solution. There are two steps. The first one is to calculate number of mole of phosphate. We can see here 1.75 liter times 0.460 moles per liter, or this is represent the molarity. So we can get 0.805 mole of sodium phosphate. The second one is how we want to calculate the mass by multiplying the molar mass of sodium monohydrogen phosphate. From number of mole of sodium monohydrogen phosphate 0.805 mole, we times with molar mass of sodium monohydrogen phosphate 141.96 gram per mole. So, when we cancel out the unit mole, we can get 1.44 gram sodium monohydrogen phosphate. So then, we can get the mass. Solution always relate to dilution. Okay, let's learn how to calculate the amount needed from stock solution to prepare dilution solution. This green bottle represents you the concentrated solution which have 6.0 molar of isotonic saline. Isotonic saline is sodium chloride solution, while in this blue bottle contains 800 milliliter with concentration 0.15 molar of isotonic saline. So we want to know how much we need to take out the volume from 6.0 molar concentration. There are two steps here. The first one is to calculate number of mole for dilution because we already have the complete information to calculate number of mole. In calculating number of mole for dilution, we always use this formula. Number of mole equal to concentration times volume. Or maybe we are more familiar with this formula. N equal mv per 1000. 1000 represent the ratio conversion between 1 liter to 1000 milliliter. Here, in this calculation, we want to calculate number of mole of sodium chloride. So, we have a concentration 0.80 liter and the molarity 0.15 mole per liter. At the end, we can get 0.12 mole of sodium chloride. When we get this number of mole, so it's easy to us to calculate volume for the concentrated solution. 0.12 mole divided by molarity. So we can get 0.020 liter stock solution. In another word, we should take out 20 milliliter from the stock solution to prepare the 0.15 molar diluted solution. The most common formula for the dilution is M1V1 for concentrated and M2V2 for diluted. Right? So, let's move to another question. We want to calculate amount of reactant and products in solution. Based on this figure, we can see our stomach. In our stomach, we have hydrochloric acid. Oh, so you got a pain and you eat a pills. The pills contains magnesium hydroxide, 0.10 gram. And when it reacts with the hydrochloric acid, how much we need? Okay, I got the idea. So, let's do the calculation. We eat a pill containing magnesium hydroxide. React with our stomach acid. So we can get the magnesium chloride and molecule of water. Okay, so we need to balance the equation. It should be 2 here and 2 mole of H2O. So we have the balanced equation. Based on the equation, we have a 0.10 gram magnesium hydroxide and 1.01 molar. So the first one, we need to find number of moles of magnesium hydroxide. Okay, so from 0.10 gram magnesium hydroxide, we divide by molar mass of magnesium hydroxide, 58.33 gram magnesium hydroxide. So we can have 1.7 times power of -3 mole of magnesium hydroxide. Based on the stoichiometry, 1 mole magnesium hydroxide equal to 2 mole hydrochloric acid. So if we have here 1.7 times power of -3 mole magnesium hydroxide, so how many mole we have for HCl? Right? So the second step here, okay, to calculate number of mole HCl based on the stoichiometry. So what we can get here, 1.7 times 10 power of negative 3 mole magnesium hydroxide. And we rearrange according to the stoichiometry. So 1 mole magnesium hydroxide and 2 mole HCl. So we can get 3.4 times power of negative 3 mole HCl. Okay, so the next one, when we can get the number of mole for HCl, definitely we can calculate the volume of HCl. Okay, when we deal with the concentration, the formula that we always use is number of mole equal to mV. M for molarity, V for volume. Or maybe sometimes, okay, we are preferring to use mV per 1000, where the 1000 is referring to the ratio 1 liter to 1000 milliliter. Okay, based on this equation, we want to calculate the volume, so we can rearrange to the equation volume equal to number of mole divided by molarity. Let's check it. Okay, so for the volume, so we have a number of mole 3.4 times power of negative 3 mole HCl. We need to divide by the molarity. Okay, 0.10 mole per liter. Alright, so at the end, we can get the volume is around 3.4 times 10 power of negative 2 liter of HCl. Or in other words, it means that we need only 34 milliliter of HCl to react with magnesium hydroxide. Okay, done. We're already done with this question. Let's check out another question. Okay, this time we will learn about the calculation regarding limiting reactant in solution. In a simulation mercury removal from industrial wastewater, 0.050 liter of 0.010 molar mercury 2 nitrate reacts with 0.020 liter of 0.10 molar sodium sulfate. It's the same with the equation here. And how many grams of mercury sulfide will form? Okay. So let's do calculation together. Okay, so based on the equation, we can transform the information to the chemical formula and also some information. So here the information, we have a mercury nitrate with the concentration 0.01 molar and the volume 0.05 liter. Meanwhile, sodium sulfate have a concentration 0.01 molar with the volume 0.02 liter. And the question is, how much mercury sulfate produced? Okay, as usual, this part is our reactant and this part is our product. The first step, we should calculate number of mole. Let's say if we choose mercury nitrate for the calculation as limiting reactant. Okay, so we can see here, the first one, we need to calculate number of mole. 0.05 liter times the molarity 0.01 mole per liter. So we can get 5 times 10 power of negative 4 mole mercury nitrate. So the second step, based on stoichiometry, 1 mole mercury nitrate equal to 1 mole mercury sulfate. If we have 5 times 10 power of negative 4 mercury nitrate, it means that we also have 5 times 10 power of negative 4 mole mercury sulfate. We're done with the mercury nitrate. Now, let's change to sodium sulfate. How many mole mercury sulfate can produce from sodium sulfate? Here the calculation. If we choose sodium sulfate, so the number of mole of sodium sulfate is 0.02 liter times the molarity 0.01 mole per liter, we can get 2 times 10 power of negative 3 mole sodium sulfate. Based on the stoichiometry, 1 mole sodium sulfate equal to 1 mole mercury sulfate. Now, if we have a 2 times 10 power of negative 3 mole sodium sulfate, it means that we also have 2 times 10 power of negative 3 mole mercury sulfate. All of these, we can combine it in the style of writing like this. We just can combine these two steps. This here refer to the step 1, calculating the number of moles mercury nitrate, and here based on the stoichiometry, so we can get the same answer. It is similar with the sodium sulfate. If we see this side, it will refer to number of mole sodium sulfate, and this side refer to stoichiometry. At the end, the result is the same, 2 times 10 power of negative 3 mole mercury sulfate. Before we can get the mass of mercury sulfate, we need to determine limiting reactant. Can you give me which one is the limiting reactant? Limiting reactant will limit the production of product. Yes, our limiting reactant now is mercury nitrate. Because it has less number of mole of mercury sulfate. We're done with the limiting reactant, so now we move to calculate the mass of mercury sulfate. From the previous calculation of limiting reactant, we get the mole of mercury sulfate is 5 times 10 power of negative 4. So, when we want to calculate the mass here, we need to do with the molar mass. Based on the usual formula, number of mole equal to mass over molar mass. Now, if we want to calculate the mass, so we should times the number of mole with the molar mass. Molar mass of mercury sulfate is 232.7 gram per mole. Okay, so we can cancel out the unit here. So at the end, we can get the mass is 0.12 gram mercury sulfate. So at the end of the reaction in wastewater treatment, the mercury sulfate produced is 0.12 gram. Okay, so we did the calculation. So we arrive at the end of our lesson. Hopefully, you can know how to calculate the limiting reactant in solution. That's all. See you in the next class. Thank you.